Okay, Lexi, and here is number 24 from lesson 53. So if you'll follow along with me on your sheet, that would be great. Okay, so what we have here is we have a parallelogram. It's called SPQT. We're told that line segment PQ is congruent to TL, so let's go ahead and mark that. PQ is right here, and TL is right here. So those two line segments are congruent. So the first thing we'll go ahead and look at is what is it that we're trying to prove. We're trying to prove that, I'm going to put this in a different color, that angle PSK is congruent to angle TQL. So let's go mark those up so we know where those are. Actually, I'm going to do those in green. PSK is right here. And TQL is right here. Okay, so we're trying to prove those two green angles congruent. So one of the things we kind of begin to look for is that we're trying to prove triangles congruent, because think about it. If I can prove that this triangle here is congruent to this triangle here, then that would be all I would need to be able to say that those two angles that we marked in green are congruent. Because remember, if two triangles are congruent, then all of their corresponding parts are congruent as well. So let's see if we can go towards that. All right, so parallelogram SPQT, that's the first statement, and we're going to fill in that that was given. So that's just telling us that that is a parallelogram. We have to know that because a parallelogram has special things that we need to know about it. If you remember, we've talked about, first of all, in a parallelogram, I'm just going to kind of sketch this out right here. We're told that the opposite sides on the parallelogram are parallel. That's the first thing that we know. We also know that their opposite sides are congruent. Remember what I showed you on the table on Thursday? It turned out to be kind of a messy little example because I didn't have straws like I wanted, and I was trying to show you by laying out all those pens, and I started it as a rectangle, and we know that on a rectangle, we know that all the opposite sides are congruent. And remember, I started it out that way, and then as I started to slant the sides, the two sides, left and right sides, I started to slant those, and it doesn't change the length of any of the sides, so it remains true that the opposite sides are still congruent. Okay, so those are just some of the parts that we learned about parallelograms. So it's important that they tell us that this is actually a parallelogram and that we don't just assume it, because now we can use that in our proof. Okay, so we said that PS and QT, no, we didn't say that yet. That's what we're going to say right now. I'm sorry, I thought that was one of the given pieces of information. It's not. Okay, so let's look at step 2 here. The statement, we're going to figure out, because it's a parallelogram, now we know that PS is congruent to QT. And that comes from, you might want to write here, this is theorem 35. And theorem 35 says this: if a quadrilateral is a parallelogram, then both pairs of opposite angles, sides are congruent. Let me look, maybe it's not 35. A quadrilateral, then both pairs of opposite angles. We want to say opposite sides. It's 36. Because we're talking about opposite sides here. So 36. Theorem 36 says if a quadrilateral is a parallelogram, I'm just going to draw a parallelogram symbol, then both pairs of opposite sides are congruent. Okay, and that's why we can make the statement that PS is congruent to QT. All right, let's look at step number 3. Okay, we can also say, now I'm looking here, PS Let's look at another thing we know about PS and QT. We also know that those are parallel. PS is parallel to QT. And that comes from definition 45. If you have a parallelogram, then you know that the opposite sides are parallel. Now, why does that help us? Why do I need to know about those being parallel? Well, if I look, remember what we know about parallel lines. We studied a lot about having parallel lines, something like this. And you have a transversal coming through, right? And it creates all kinds of special angles. Well, we have that going on even in our parallelogram. So let's look here. So if this line, and I'm going to erase it in just a minute because we're going to get too busy here. But if this line is parallel to this line, which is what we just said, based on the fact it's a parallelogram, I'm going to look at this transversal right here. Okay, and why am I wanting to do that? Well, because I'm still trying to prove enough to say that triangle PSK that I marked in yellow and triangle QLT are congruent. Right now, I have two sides that are corresponding and congruent, but I need either another side or an angle. So based on those two parallel lines that I did in purple and that transversal cutting through there, I can see that I have alternate interior angles. I'm going to color those in purple so you can see those. Alternate interior angles. So SPK, that angle, is congruent to angle QTL. Why? The reason is because if two parallel lines are cut by a transversal, then their alternate, I'll abbreviate that, interior angles are congruent. That's the reason. Okay, so what do I have here now? Now I have side, angle, side. I'm going to erase some of this stuff off of here. Okay, so I have a side right here. I have this purple angle, and I have another side that are congruent. Oops, I put this one in the wrong place. I wonder if you noticed that I had done that. You're probably over there going, Mrs. Quigley, fix that. It was this one here, alternate interior angles. I put the wrong one. I remember alternate means it's on the opposite side of the transversal, so sorry about that. I didn't mark it in the right spot. Okay, let's go back to what I was doing here. Okay, so those three purple parts that I have marked there, we have a side, an angle, and a side. So we proved three parts of those triangles congruent. So we can use this now that the triangles are going to be congruent. But there's one more piece of information that we need to put in here, and that was what was given up here. PK is congruent to TL. That's given. We talked about it. I mentioned it earlier because we went ahead and marked those sides, but we need to go ahead and formally write that into the proof. Okay, so on step 5, we'll go ahead and make that statement. Now we can say that the triangles are congruent. So we're going to say that PSK is congruent to TQL based on the side, angle, side. We proved a side, an angle, and a side in each one of those triangles congruent. Therefore, PSK, and I'm going to write this in green because when we started, I said these green angles up here are what we were trying to prove congruent. Since we now have two triangles that are congruent, then that means all corresponding parts are congruent as well. So that's the CPCTC right there, and that's the end of that proof. Alrighty, so I hope you were able to get all that filled in. I hope that all made sense, and we will see you soon. Thanks for watching.